All right, so we've got Jim and Alex trying to paint a house or a building, and actually one thing I did, because I want to use units, I don't usually use units, but I want to use units, and I wanted to abbreviate like buildings over house as opposed over hours as opposed to like house over hours, because it was H over H, it was confusing. And I changed it in some of the worksheet, but not of all the others. So I'm going to just change it where it says house, I'm going to change it to building, just to be consistent. It doesn't really matter, except like I said, I'm going to use units, and I want to use B over H for buildings over hours. It'll just make more sense. All right, so Alex can paint an entire building in 25 hours. Alex can paint the same building in 20 hours. We're going to try to write an equation to figure out how long would it take both of them working together to paint the house. And so there's a way to do this that's kind of outlined here, and then there's a way that because of our warm-up, we could almost reason it out before we followed the method. But first we got to figure out their individual rates. So first of all, we've got Jim. Work is rate times time. The amount of work is one building. The rate we don't know, but we know he can do it in 25 hours. So what do I need to do to figure out what the rate is? Divide by 25, and I'm actually going to divide by the 25 and the hours to show that those cancel. Which then means, what is the units for my rate? 1/25 of a building per hour. Buildings per hour. I will be very honest. A lot of times I know I'm getting these right because all my units cancel properly. Because sometimes I forget. And I was like, okay, as long as I get my units to cancel, I'm probably doing this right. So Jim's rate is 1/25. Does anybody get a suggestion of maybe a better way to write that rate that might be easier? Yes? 0.04. I'm going to do it both ways. Okay, 0.04 buildings per hour. When you do this on an actual test, you can choose, although once again, if you use like a 1/3 or a 1/7, there's going to be a problem because you're going to have to round that decimal. Okay, what's Alex's rate? 1/20th? It's 20 over H. So I got rate is 1/20th buildings per hour, or what is that as a decimal? 0.05 buildings per hour. Now, since we've done that warm-up, has anybody already figured out how long it's going to take them to paint this house together? Okay, we'll come back to that then. All right, so down here, we're going to try to figure out collectively using this formula, and you do not have to use this formula as long as you can justify your reasoning, but this formula will work. So it's better to have a process as opposed to kind of reinventing it all the time. Alex, you got it figured out already? 11.11 sounds right. Let's see if we can get that together. All right, so the work, I'm going to do this two ways. I'm going to do it with decimals, and I'm going to put units in, which I don't normally put units in until the end. And then I'm going to do it just with fractions, because one of the reasons we're doing this is to show that, hey, if I got fractions in my equation, it's easy to get rid of them, because we're used to that now. All right, so our work up there is one building, 1B. Jim's rate is 0.04 buildings per hour, and we need to multiply that by some unknown time, because that's what we're trying to figure out. And so we're using this equation up here. And Alex's rate is 0.05. It's a T. Buildings per hour, and that's also times a T. It's a kind of a cursive T. All right, now, looks like I got two T's in the equation. Any suggestions for how I get just one T? I could divide it out, or I could factor it out. Either way, I'm going to factor it out front. I'm going to bring the T out front, and then you'll say, oh yeah, I knew I was going to be able to add those rates together somehow. So I'm going to just bring the T out front. So I got 1B, the T is going to come out front, and so what's left over when I factor the T out is 0.04 buildings per hour and 0.05 buildings per hour. Which at this point we're like, oh yeah, I knew I was going to add the rate somewhere, because that's what we did in the warm-up. All right, in a second it will be clear why am I doing all these units. I got time, 0.09 buildings per hour. What's the one step I have to do to figure out my time now? Divide. And I'm going to divide by both the number and the units. What happens to my buildings over hours when I divide?
It cancels
They cancel. When I do it on the other side, 0.09, buildings over hours. What happens to my buildings on the other side? They cancel. What's my unit that's left? It's hours, because that 1 over hours in the denominator becomes hours in the numerator. So it's 11.11 hours. Because the B's cancel.
That makes sense.
Okay. And like I said, I'll be really super honest. A lot of times I'm not sure if I'm setting these equations up right, and as long as I make sure my units kind of cancel properly, I'm usually setting it up right. All right, so I just want to show you how you can do this with fractions, and I'll be honest, I did not do any of these. I did all these worksheets ahead of time, and I hadn't seen them before. I didn't do anything with decimals. I did everything with fractions because I thought it was easier. I thought it was quicker. I knew I was going to have to round anything. Most of it I could do in my head. All right, so we're going to do it with fractions now. I got one building. Jim's rate in fractional is 1/25 times t, and Alex's is 1/20 times t. If this was on the quiz tomorrow, how are we going to get rid of that 20th and the 25th? Are we going to get everything to a common denominator? And you could. That'd be the hard way. What would I rather do than have a bunch of denominators? Multiply by what's our least common denominator? Well, it's going to have a 5 in it. What else is it going to have in it? A 4 and another 5. It's going to have 100. That's 5 times 5. That's 4 times 5. So my least common denominator is 100. All right. So let me show you. This is how my mind works when I'm canceling this stuff. 100 is 25 times 4. I got a 25 there. What's left when I cancel the 25s? 4. 4t. 100 is 20 times 5. What happens what's left when I cancel the 20s? 5t. Now we have a pre-algebra style problem, except for the fractional answer, which we get exactly the same answer we got the other way. This is actually the way I did all the problems. I did everything with fractions, because to me it was easier. Okay. Anybody still looking at this side? All right. You done? Okay. Other side. Problem number 1's almost exactly the same. You're going to work it out on your own. Problem 2 is going to require a little bit of thinking. All right. I need your attention for about another 5 minutes here. Gabe, you with me? Yeah. Okay. All right. I don't have people working. I have hoses working. They're trying to fill a fish pond. Together, they take 12 minutes to fill a pond. One hose is able to fill the pond 10 minutes faster than the other hose. I don't know why they couldn't just tell us how fast that was. How long does it take each hose to fill the pond by itself? So we're going to use that same formula. We're going to use work equals rate 1 times time plus rate 2 times time. We need to know all but one of those variables in order to figure this out. Otherwise, there's too many variables without having another equation. So do we know any of those numbers?
Yeah.
What do we know? We kind of know the rates. What do we definitely know? 12 minutes. So we got 12 times a rate, and we got another 12 times some rate. Oh, I just did it that way. What's my amount of work? How much work am I getting done? One what? One pond. So I'm just going to remind you, our work rate is pond over there. One pond, if it was 2 ponds, it'd be 2. If it was 3 ponds, it'd be 3. But for one pond, 12 minutes to fill using the hoses. All right, now the rates, this is why I'm doing it with you, because this is a little hard to figure out. One of these is faster and one is slower. Which one do you want to be faster?
Rate 1.
Okay, everyone always... All right, what are our units? Is minutes in the top or the bottom? It's a rate, it's got to be something per something. So we're measuring in minutes. So what's our unit in the top? Ponds. Ponds per minute and ponds per minute. So once again, I think writing down the units makes me think, okay, I kind of know what numbers go where. So in the top rate, how many ponds? 1. In how many minutes? Not 12. Do we know how many minutes?
10 plus.
No. So let's make it an x. So what's going to be the unit for my other one?
X minus 10.
Is it x minus 10 or x plus 10? This is where you could get backwards. All right, so we're talking about minutes. This is x. The other minutes, does it need more minutes or less minutes? It's slower, so is it going to take longer or less time? More. So that needs to be x plus 10. If you get that backwards, at the end, you're going to realize it because either it seems wrong or you maybe get a negative number or something like that. But that's an easy place to make a mistake. So now we can just plug those in. We get 1 over x and 1 over x plus 10. That 12 is all up in the numerator. If you want to put it over 1 to remind yourself of that, do so. I had a lot of people that threw people off a little bit. This looks a lot like your homework problems from last night. So how do we want to start solving this? Let's multiply. So a lot of people suggested I divide by 12 first, and that would work, but that just gives me a fraction, so I'm not going to do that. Multiply by what? You want to get rid of the x or the x plus 1 first? I got both. I'm going to do it one at a time. So let's just get rid of the x first. I heard somebody say x. But you can definitely get rid of both if you want to. So I'm going to multiply that 1 times an x. I get x. What's going to be my first term over here when I cancel? Just going to be, the x's are going to cancel. I'm going to be 1 over 12 on top, or just 12. Is anything going to cancel in my second term? No. It's going to be 12x over x plus 10. All right, what's the last step I need to do to turn this into an Algebra 1 style problem? Multiply by x plus 10, both sides. All right, now that I've done this, what's the one kind of problem with how to finishing this answer? What's going to be a little bit hard about figuring out this answer? It's going to have a square in it. It's going to be quadratic. So I got x squared plus 10x. I'm going to distribute this. I'm going to do some work in my head. 12 times x is 12x. 12 times the 10 is 120. So I did the 12 times the x plus 10. And then, do I do 12x times x plus 10? No. I need to, well, technically I do, but then I cancel. Yeah, right. Okay. 12x. Okay. Going to do some more mental math. I got x squared. I got 24x on this side. What happens when I bring it to the other side? Negative 14, because the 10x minus the 24x. I'm moving everything to the left side because I got to do that. And then, what's my other term? Negative 120. Now, hopefully, this is factorable. So I'm going to stop it right there. So we just figured out that this factors to x minus 6, no, x plus 6 and x minus 20 equals 0, which means x has got to be what? Negative 6 or 20. Are both those answers right? Yes. Anybody want to tell me why one of those answers is wrong? Yeah, Gabe? Yeah, you can't. We can't do negative time unless we're in some kind of science fiction world. So the negative 6 won't work in the rate 1. So this one is kind of an extraneous answer, because there's no negative time. So if we plug it back in, my rate 1 is 1 over 20 ponds per minute. Our rate 2 is 20 plus 10 is 30 ponds per minute. I have no idea if those are right, so how could I check? Plug it back in. So what do I need to multiply the 1/20th by? How much time? 12. And then what do I need to multiply the 1/30th by? Also 12. And if 12 times 1/20th times 12 times 1/30th is 1, which it is, we did it right. Let's also reason this out. If that's right, 20 minutes to fill the pond, how fast could it fill half the pond? 10. If that one had half the pond, how long would it take? 15. So somewhere between 10 and 15 is a good answer, because if they were both filling, at some point it's going to almost be done at 10 minutes, but not quite. And then so it's going to take a little while longer. So that 12 minutes that was in the original problem seems like a good clue that we probably got the right answer there. So it's always good to kind of go back and break it down and think about, does that answer make sense?